Okay, so what I'm going to do is I'm going to make a solution of polymer, and then I'm basically going to do a real quick beaker test on how we do the sludge dewatering aspect of the labs. So the first step is I'm going to put 200 milliliters of water into a sample bottle, something that I can shake up. This can be anything you have available, even mason jar or whatever. I have a graduated cylinder, so I'm going to put 2 of these in 200 mLs. And this is an emulsion polymer similar to the K279FLX, which you're using. I got a sample of sludge from the digester. They ran it yesterday and it was 1.8% solids. So we're going to use that as a base for our calculations, but this is just for demo, so it doesn't really matter. I have the polymer that I captured. I have a 1 ml syringe, which I'm now going to put inside this where I put the 200 mLs. And just shake that up and mix the polymer up. You can do this with a mixer or however you want to do it. And what I'm going to do is give this just a second to kind of, I don't think cure is the right word. Polymer has to open up, so it's more efficient if you give it some time to work. I'm going to be doing 5 ml samples. So now I'm going to get my sludge. I have 2 beakers. I'm going to fill these to 200 milliliters. You can see this is what's come through the digester, or what will be coming from the digester to his press. He actually runs a screw press, a little bit different application. And Todd, there's no rush on this. His unit's down anyway, so we have plenty of time to get this converted to however we want to do it. I'm going to have to find something to transfer into. So I have a 10 ml syringe, but I'm going to do these 5 at a time. So what I'm going to do is work up my dosage till I find my best dewatering. Okay, I have 5 mLs pulled into a syringe. I'm going to put that into the second beaker. I get just a slight amount of water so I can kind of move it around. And now I have my sludge sample. So I'm going to tilt this slightly so we can see what's going on. We're going to do 10 turns. 1, 2, 3, 4, 5, and nothing's really happening by now. I should see some breakout, but I don't really see anything happening. So I'm going to go ahead and take it up to 10. And pull more sludge. This will end up being about 20, very likely, from what I've done in the past here. Rinse those real well, get my 200 ml sample. Better if I had something, I just didn't have anything available to pour this into. I go by 5s, and then after I kind of find it, I can narrow those from 5 to, like, say I got the 20, I could try 18, 22, kind of get in the range. But I got 10 ml in. Got my sludge. 1, 2, starting to see a break. 3. Actually, I don't know if you can sit there, there's block in there. 4. It's going away, so I'm going to go ahead and take it to 15. a good way to do this is get these solo cups, but get the clear ones, and you can actually kind of see it a little bit better. Now I'm going to take it to 15 mLs. These solids are a little bit low at 1.8. They can actually make your dosage higher. I like to say about 2.5 usually to run these. All right, I got my 15. Got my new sludge. 1, 2. There we go. 3. See the clean water break happening. 5, 6. So we're not there. Going away. I'm going to take it to 20, which is kind of where I predict that's kind of where this runs. Every plant's different. 200 mLs of sludge. Got 20 mLs of polymer. There's 10. Got 20. Your hands get really slick from this stuff. 1, 2. Good break now. 3, 4, 5. It's still going away there. I like to see this stay together through all 10 turns. But I did get a break and there's some flock. I'll go ahead and bump it to 25, and then I might come back down if I need to. Get my 200 mLs in here. You're fine, Chris. You ain't no way. 5, 10, 15, 20, 25. All right. Hopefully this will be enough to demonstrate. 1, 2. There we go. See the break, clean water breaking out. 3, 4, 5. I'm going to stop there just to demonstrate. This was pretty good here, but you can see I can actually pour clean water off the sludge. And saying clean water is kind of a, what you compare it to, I guess. I'm recovering pretty much my 200 mLs is all recovered into that. I'm gonna drain as much as I can. Anyone see that? I think that's good. That's our clean water that we pulled off.
Wow.
And I'm gonna see if I can squeeze more water out of it. I don't know if the camera's not gonna be very well there, but I need to be over the sink to do this. That I can squeeze out. And it doesn't come around. And I dropped it. I'm not good. Let me do one more just because I lost my sample. You see, I'm making flock that's very easy to continue to squeeze, and that's what the centrifuge is doing, is squeezing that water out, or like the belt press, which basically crush it, push it out. And the reason I'm seeing if anything comes around my fingers, like on a belt press, that would leak around and would be inefficient. So we're looking for efficiency. This is very subjective. You got to consider it's just kind of something you do over time. I'm gonna do one at about 22. I may have been a little bit overdosed. You kind of get in that range. That's so when I get to my fives, I'm probably gonna do like 18 and 22, 19, kind of wherever that number may lay. I can then take that, convert that to a part per million, and give you basically a pump setting on your equipment. I got 5. 10. 15. There's 20. And yeah, let's do 22 and just kind of see what that looks like. And I would probably, if I were doing this, I'd be recording my findings. I'd say, okay, I lost it at however many turns, or it got stronger or weaker here. But just for demonstration purposes, I'm just trying to show you what I like to see as the end result. 200 ml sample again. 22 ml polymer. 1, 2, 3, 4.
Wow, that's amazing. Good visual.
5, 6. Yeah, 7. It's holding together better than it was last time. So I'd overdosed it and kind of went away. 10. Okay. Now that time I did a full 10 turns. I'm looking for, is that water clean? That tells me the charge is right. That's cleaner at 22 than it was at 25. See how fast it's pouring off there, holding that together. So I got clean water. I mean, it's not clean, like water clean. Now I'm gonna kind of get a hold of it, start squeezing it out. And we're making little sausage patties with our sludge. Not uncommon to see other things in that sludge, corn or whatnot. Yeah, when I can make, then many times what I'll do is I'll lay this on like a paper towel and it'll suck that out and this thing will be cracking from what you've done. But just for the audience watching now, the reason we do this is we took all this water out of that sludge. So the hauling cost for this is substantially lower than hauling the stuff I pulled up before I started the polymer. It's a lot of weight and water. So they're weighing this, and actually the dosage I'll acquire is called pounds per dry ton when it's finished. But I can squeeze the crap out of this and nothing's like coming apart.
That's amazing.
That's the end result of what we're trying to do. But the procedure again is we're going to make a 5 gram per liter solution, 1 ml and 200 mLs of water of your polymer. And then I'm going to work it by 5s with 200 ml samples until we get a number. Then you call me and I will figure out the feed rate for your pump.